Alright, so this is Computer Science 305, and this is the second exercise from the Syntax and Semantics Part 2 in-class exercises. So we start out with a grammar. Round. And this grammar is basically giving us a language where we have pairs of parentheses followed by a set of parentheses followed by a set of square brackets, where inside the parentheses we can have either we can have only parentheses, or we can have, and inside the square brackets we can only have square brackets. And so this is an inherently ambiguous grammar. It cannot be made unambiguous by its definition. But what we can do is we can prove that ambiguity by showing that it generates at least 2 parse trees for any one string that comes in. I'll do that just shortly here. Let me just finish up what's going on with this. Square. And just 2 more. Okay, so this is our grammar. It's a pretty simplistic grammar to understand. And so to prove this is ambiguous, we simply just need to figure out if there are any one string coming in here that will generate more than one parse tree. So the most basic string that can be generated is simply a pair of parentheses followed by a square bracket, a pair of square brackets. Alright, so we could think about how this might go. So we start with S, and then it can go to an outer, right? If we start at S, and then we see outer, we go to outer, and then it would have an outer or an inner. Well, let's say that it has an inner, right? So the outer part, so if we said inner, that matches to the outer parenthesis and the outer square bracket, and then we have inner, right, which then matches to the inner 2 brackets. Okay, pretty simple. Well, we also could say, we could see this again. And we can start with S yet again. And the interesting thing is we could go the other direction, which is through round and square. So we have round and square. And round would then match this, and square would match this. So then that shows us that we have 2 possible parse trees for the same string, thus ambiguous. We put a little square on the bottom, or QED, that which has been proven. Alright, so that wraps up that solution. It's pretty easy to understand. Typically whenever we solve for try to show these that the parse tree is that the grammar is ambiguous for these simple grammars that we're looking at, typically we only need to pick the most simple actual strings that could come in. In this case, we literally selected the simplest string it could possibly generate. and lo and behold, we showed that that comes up with at least 2 parse trees for that simple string. We could easily show much more complicated ones, but this suffices for exactly what we're trying to do. So anyway, I hope that everyone can see that's how I was figuring this out. If you have questions, please come see me either during my office hours or ask them in class, and I will gladly answer and make time to answer anything or help you understand what's going on. So anyway, I'll see you in class. Have a great day.